Edelweiss has a built-in calculator. You can access it up here in the toolbar, and this has some convenient functions for scientific calculations, and it will also keep track of the units. If you just want to do some simple unit conversions, there's a separate tab up here, and here you can fill in different values, like for example 5 psi. I use tab to choose the unit, and tab again to choose the second unit, and then press the convert button to perform the unit conversion. Now I can just input different values here and it will always do the conversions on the fly. As long as there's an equal sign here, these two values are equal. If I change the unit so that it's no longer possible to convert, there will be a not equal sign. But if I put something where it's possible to convert, I can press one of the convert buttons to choose which direction the conversion should be performed in. To demonstrate how to use the calculator functions, I would like to use a little example. So if I move the main window away, I have here a sketch of an experiment. It's not really necessary to understand every part of this experiment or the calculations, as it's just to demonstrate how to work the calculator. What I have here is a solid-state battery with an anode, an electrolyte shown in purple, and a cathode, and it's 1.5 millimeters thick and diameter 12 millimeter. And in the middle I also have a wire which will be the reference electrode. And this wire, which is shown here in cross-section, is a gold-plated tungsten wire core, which is 25 micron in diameter, and then a layer of lithium metal is plated on top of this wire. And as shown here, it's done by constant current, and the lithium anode here is used as the counter electrode, 5 microamp per square centimeter of the lithium anode for 30 minutes, and that plates some lithium on this wire, and the question is how thick is this lithium layer? To start, we should calculate what was the actual current used. So we had 5 microamps per square centimeter, and the relevant area here is the area of the anode, which is a circular disc with a 12 millimeter diameter. To calculate this area, we could put in here in the input value 12, and then tab to go to the unit and millimeters, divide by, and then 2 equals to get the radius, then press the square to square this, and then multiply by pi. Here you can use the physical constant button to input different constants, and pi is one of these. So we can multiply by this. I press the multiply button and then equals, and here's our result. There's actually a quicker version. If I clear this, there's another button for circular area that I can click, input the diameter. This is already actually what we want, and that already inputs the area as the input. So what we want to do now is to multiply this by the current density, which was 5 microamps per square centimeter. So I put 5 and then tab to input the unit, which was microamps per square centimeter, equals, and then here we get our current. This was applied for 30 minutes. So to get the total charge that was passed, we will multiply by 30 minutes. Multiply equals. So as you notice, this just multiplies the units without doing any kind of simplification. If we want a more reasonable unit than microamp minutes, we can press the simplify result. Now we get it in millicoulombs. To get the amount of substance that this corresponds to, we need to divide by the Faraday constant, which is also available with the physical constant button. Faraday constant. So you can see this in coulombs per mole. If we divide by this, we get an answer now in moles. Next, we need to calculate how large volume this many moles of lithium corresponds to, which means that we need to multiply by the molar volume. And the molar volume of the different elements are actually available using this button down here called element property. This brings up a periodic table, and we have here different elements and different categories of properties. And under each category, we have a number of these different properties. And if I choose physical, what we want is the molar volume that you can see here. And if I choose OK, it will input it as the input for our calculation. So this is in cubic meter per mole. If we multiply with this, we get the answer in millicubic meter. We can simplify the results. Then we get a result here in nanoliters instead. The question was how thick this layer of lithium, which is about 1.37 nanoliters, corresponds to when it is spread over this wire. And for this, we should then calculate the volume of a hollow cylinder. But to simplify things, I will neglect the curvature of this and just assume that it's a block. And I will divide this volume by the surface area of this wire. And this will be good enough. We're already assuming, for example, that we have a perfect layer of lithium that is non-porous. This simplification will not be the largest source of errors in this case. So next, to get that surface area, we should multiply this circumference by the length of the wire. So perhaps I will just first of all store this volume. We can do that by clicking this alpha or beta button. Now we get this result stored away, and I will press clear, and then we will take this diameter, which is 25 micrometers, 25 tab and micrometers, and we multiply by pi again to get the circumference, and then multiply by the length, which is 12 millimeters. So times 12 millimeters. And this here is our area. Maybe we store this to beta, and we can choose recall. First I will do clear all, and then when I press alpha now, it will recall this value to the input, and I choose divide by beta equals, and then we do simplify results to get a better unit. And then here finally is our result, 1.45 micrometers. So this layer will be about 1.45 micrometers after this lithium plating. If I wanted to, I could now press the copy result button to copy this to the clipboard. And now I can paste this somewhere else in the project. And that is how you can use the built-in calculator in Edelweiss.